Good evening, guys. So we are here to continue with the physics class. Yesterday we were dealing in mechanics as a whole. All the chapters, topics we covered as a whole. What are the parts of mechanics? Like how do we should approach towards mechanics. Now today we are into a specific chapter of mechanics. One of the most important chapter. A chapter which sometimes feels us to be very easy and sometimes to be very complex. A chapter where universal laws are always directly applied. A chapter where Newton's laws are directly applied. So we are here. I told you Newton's laws of motion. Okay, this forms the streamline, or you can say as the bloodline of whole of the mechanics, right from now, from 11th standard till engineering or any degree you pursue in future. If it's related to science and physics, Newton's laws of motion will always be considered as the most important, and it forms the basics of all the chapters of physics. Sometimes what happens is that we say that okay, Newton's laws of motion is not followed for quantum physics. Now why do I say so is because that is the only exceptional part of physics where we say those things sometimes. But if you get into the miniacs of the physics, even in quantum physics, some or the other ways it is always applied. The difference remains, what there. I'll tell you very frankly today that atom has a dual nature. Atom has a dual nature. That means atom has a particle nature as well as atom has a atom has a wave nature. Now for something to be a particle, mass is important, and for something to have a wave nature, wavelength is important. If anything has a wavelength, it is always considered as a wave, and if something has a mass, it is always considered as a particle. So when we consider atom as a particle, there the Newton's laws of motions are for sure applied and is valid and is correct. But when we consider this as a wavelength, then we need to be very cautious while applying Newton's laws of motion, because Newton's laws of motions mainly deals with the motions of a particle. Okay, now today I'll tell you some very laws of Newton's laws of motion. First of all, the first Newton's law. The first law says that any body or any particle remains or tends to be the state of motion or in the rest until and unless acted upon by an external agent. What does that mean is, if a body is moving, it will keep on moving. If a body is at rest, it will be at rest until and unless we apply some force to it. That must be external in nature. Internal forces doesn't matter. Please be clear. I remember in NCRT, in the solved examples also and in the exercises also, there are 3 or 4 questions related to what I have said right now. All the statement whatever I deliver in the videos are either related to NCRT questions or the past years of IIT or NEET questions. So if you listen to my videos carefully, you can easily solve them out on your own. Now the questions in NCRT regarding this is that whether when we talk about this Newton's first law, they ask is, so what about the internal forces? We are saying until unless an external force acts upon it, the state of the body can't be changed. Now when considering the internal forces, normally except some few exceptional cases, and it is very rare in nature, internal forces they are never capable of changing the state of the body. make it crystal clear. Internal forces have no capability regarding the change of state of the body. None of the internal forces till today discovered has been able to provide motion to a body or has been able to stop the motion of the body so that the body comes to rest. I'll share with you some examples of the internal forces. You must be, right now you must be imagining what may be the internal forces. There can be internal forces like nuclear forces, any force that acts within the atom, or any force that acts within the body by itself, that may be termed as the internal forces. So again, Newton's first law, let it be crystal clear from now on. Newton's first law has nothing to do with internal forces. It always states that the state of the body remains in the motion or in rest unless and until acted upon by an external agent. Correct? This is also sometimes called as inertial law. We'll come to know about inertial laws, but right now, please be clear. And whatever statements I said is, forms the, we can say 10% of the NCERT exercise. If you are referring Iit Jee the best book I consider for IIT and all, that is also what I said forms the solved example as well as the objective 1 and objective 2 of Iit Jee as well. Okay. Second law is more of mathematical in nature than logical in nature. Why? Because second law simply says that force is equals to mass of the body into acceleration. Okay. Now acceleration is always, now when I teach, it's all in SI unit. So for SI units, I will suggest we must be very careful about using units in physics. Force SI unit is Newton, mass SI unit is kg, acceleration SI unit is meter per second square. If anyone feels any difficulty in using these units, they can comment on the video. We will be dealing with all the SI and CGS unit. So don't feel like you are lagging behind only due to units. No, it's not like that. If you feel something complex in using the SI units, this meter per second square, kg, Newton, etc., where how can acceleration has its unit, just comment on the video. I'll give a separate lecture on this, how to use SI units. Okay. Next, this force is equals to mass into acceleration. Now there are many types of interpretations which is done in mechanics through Newton's second law. That is most important. Okay, what can be the major interpretations that can be done? I'll tell you. Newton's second law is used to interpret the linear momentum. It is used to derive maybe the laws of the equations of motions. It is used in all forms. So let it be crystal clear. Now how we'll say it right now. Now force is equals to mass into acceleration, right? This is the mathematical derivation. And now this acceleration, what is acceleration actually? Acceleration is always equals to rate of change of velocity with respect to time, right? So if we substitute this value here, so what it will be? Force equals to mass into dv by dt. Any problem? I don't think is there any problem. We have just written the value of acceleration. We have substituted it into this. Because acceleration is always the rate of change of velocity with respect to time, right? Now, if I write P equals to m into dv by dt, okay, simply I have again rearranged the things in terms of f. And what I am trying to do is, I am trying to put this here like F into dt is equals to m into dv, right? I have rearranged it. Anyone, if you can't if you have some doubts, okay, we will not follow this, because this sometimes becomes difficult to understand. Only what I was trying to do is I was trying to prove some impulse sort of terms in physics. Anyways, just remember at this level that F is always equals to mass into rate of change of velocity with respect to time. Now again, if you consider mass, of course, which is always a constant thing, so what we can derive from this Newton's second law is F is directly proportional to dv by dt. Okay, now when F is directly proportional to dv by dt, if you can understand this what I have written here, believe me, just check, just after watching this video, go through the IIT's last 10-20 years question paper, in which the questions comes from Newton's laws of motion. 90% questions you will find it comes on this principle. And what we do is, okay, we are solving several pulleys and monkeys sort of questions which we normally do in this chapter. And what happens is, where does the IIT ask questions from is this simple interpretation of second law. Of course, IIT has to do much about pulleys, monkeys and etc. But what they want actually to look at is whether you can interpret this or not. Okay, I have written this mathematical formula. I have just substituted acceleration equals to dv by dt. But how about interpreting it? That is simple is, from here we can derive linear momentum. From here we can derive impulse, that is a very huge amount of force acting for a very short interval of time. From here we can derive like even for the laws, equation of motion, v equals to u plus at, or if you substitute s equals to ut plus half at square. All sorts of formulas can be used here. Why? Because this is dv by dt in a differential form. We can easily form it into, we can cross multiply it and we can easily use it in the integral form. Okay, so these are the things which comes from Newton's second law. Now coming to Newton's third law, that is very simple, but believe me guys, ask yourself what I am going to say right now. Right now what I am going to say, you will for sure make the mistake, because 95% students does that. And that is actually not their mistake. That happens because we sometimes what happens is, okay, law is a law, and when we interpret a given law or when we state a given law, we just sometimes, as we miss the integral part of it. How? I will show you. What is Newton's third law? If you ask from anyone, they will simply say that yeah, Newton's third law is every action has an equal and opposite reaction. That's all. Now you believe it. Can you believe this law? I know 95% of students says this. Every action has an equal and opposite reaction. That is Newton's third law. That says is Newton's third law. Simply say that action and reaction forces always happens in pair. Action and reaction forces in pair. Then what they fail to understand is, if action and reaction forces happens in pair on the same body, okay, so what will happen? If this pair comes on the same body, what will happen? The body will get destroyed. So according to this, none of the things should exist in this universe, on this earth and etc. Because if you apply a brake on your vehicle, okay, and the vehicle and the brake, you are applying the brake by your legs, and the brake also applies a force on your leg. Think upon what will happen. Will you be stable on the bike? No, you will fall down. So this is very wrong, that action and reaction on the same body is not possible. Of course, Newton's third law is all about action and reaction, but it is on two different bodies. Okay, this is on two different bodies. It can never be the same body. And while stating the Newton's third law, if you are missing this very important point, believe me, you are actually stating the law incorrect. Okay. Not now, but 5 years back, this was also very important for the JEE exams, as well as it was important for your 11th board, 11th college or school exams as well. So please remember this. Newton's third law states that every action and reaction, every action has an equal and opposite reaction, but this pair acts on two different bodies. Remember it. Two different bodies. This is very important. Okay, not on the same body. So this was all about Newton's third law. Now, solving problems in mechanics, guys, believe me, today I will show you some of the very good tricks on solving problems in mechanics, how to solve it. Sometimes what happens is you'll see many large number of pulleys, many blocks, many monkeys, and then they will ask you, find out when will the rope break and all. But today it seems, what I feel is that in this class, since we have studied this Newton's laws of motion, okay, so what happens here is just revise it on this from this lecture, and then we can continue with the Newton mechanics and the problem solving in the next video, so that once you are clear with the laws, we can easily apply it on the mechanics while solving the problem. Okay, but make sure that you go through this lecture. Have any doubt, please comment, and we can really revisit the topic with a better dedications and etc. Okay, next class, please make sure that you visit my lecture, because we will be solving mechanics and the question of mechanics. Okay, so please make sure that you are clear with the laws. Okay, thanks a lot. Thank you. Please, have any doubt, comment on this video. Okay, thank you.